All right, so we're going to move on from this slide. So, all right, rapid prototyping, okay? Because prototyping is not the end product. It is a product for us to check check the functionality of the product, okay? It is used within the design portion of the process, okay? So as we're checking ideas, okay, along the process is when the prototype is made, not the final product. So prototyping and additive and the final product are different, okay? So to say that additive manufacturing is prototyping is not true, okay? The other thing about rapid prototyping is that it doesn't have to be additive, okay? It doesn't have to be additive. So additive is about adding material to previous materials, okay? Over here I got a router, okay? A CNC router that can be used as a rapid prototyping machine, okay? And so, but it isn't an additive machine, it is a subtractive machine, okay? It takes stock material and removes material to create the end result, okay? So it's the idea of, us taking a chunk, a block, a pre-made block, and then cutting away would be subtractive. Okay, if we're looking at on an inventor or SolidWorks type of process, okay, you're talking about a cut extrusion or a boss. Okay, that would be a subtractive process. Okay, where a additive would be more like another boss body. Okay, on SolidWorks, or an additive feature within an extrusion. So that's why I'm trying to really talk about the differences among the two. Okay, so the power of additive manufacturing, why everybody loves it. It creates parts using only data from the 3D model. Okay, it is generally considered so easy we can teach our grandmas to do it. And I'm just exaggerating. Grandmas generally can't do a whole lot of, would be scared about how to do this, could really do it. And so I'm just making a generalization, okay? It sounds really simple. Additive manufacturing really simple. I'm using the Stratus F170, okay? And this may say 270, okay? Yeah, this is a 270 or a 370, and I'll show you why. So it's relatively simple. So you take a CAD model, whether you download it yourself or you use it on one of many different types of CAD software, okay? You then simply create the CAM, okay? You use simple CAM software, whether it's one of the built-in features within SolidWorks and Inventor, and I think they actually both do have CAM softwares or 3D printing. SolidWorks, I know, has some of the subtractive type stuff built in, where Inventor doesn't. You have to use a different post-processing. You have to use a different processing software. We use GrabCAD Print because GrabCAD Print works very, very well with this Stratus. The one that died because the mouse ate it used a different one. Okay, a little bit harder to use, but they are generally they have simple CAM softwares, which the CAM software takes the three-dimensional geometry that the user makes within the CAD software, transposes into a different type of information that the CAM machine, or the 3D printer, okay, the additive manufacture machine, can use, okay? And then it creates it really, really quickly. You load the material in the machine, you make sure it has the 2 to 4 tools that it needs, and you hit print. And it goes, okay? And it does everything that you want it to do. So I want to say load material. So looking at our Stratus, this one here, this is either a 270 or a 370, and really the differences among them and ours, which is a 170, is the number of spools, the different number of different materials in which you can print with, okay? And over here, you have your heads, which are over here. They're a little bit hard to see. And so this object here is really this printer is actually very, very easy to use because you have your 2 to 4, and on here your number 4 is going to be your support material if you're using that type of material. So in ours we use a lot of ABS plastic, which uses a support material. Well, this one here we can print something with 3 different colors. Okay, so it's going to have 3 heads and a support material, and that's how it's going to work. Okay. In here, you got a basic oven, which bakes it, okay? And you have a tray, and you have a door, and everything else is electronic, where you aren't telling it a whole lot to do, and they're considered very, very easy to use, okay? This one here, you put a little bit of wire in, and it automatically grabs it. And so it's really, really cool, but it can be a headache, too, along the way. So that is why everybody loves additive manufacturing. Okay, so I got a little bit of a story that has happened over the past few weeks. Okay, so here it's story time, and this is kind of a dilemma with what is going on and what makes additive manufacturing not as easy as everybody wants it out to be. So we're gonna start. I'm gonna tell you a story about this kid. Okay, this kid. Okay, so we have this kid, and this is just one kid. This is just one of thousands of stories like him. So this high schooler with his 3D printers at his house runs mass production line for Seattle-based hospitals. So we have so this Seattle-based kid had some 3D printers at home. He decided to start printing mass. Okay. I've heard this story so many different times from so many different places. Yes, these guys are doing great things, okay? Don't get me wrong. They're doing great things. But everybody's doing it, including Impact. So it really isn't an isolated thing that these guys, and how it works is they're printing a piece here that goes on top where you put a thin piece of plastic that slides over top, and then there's a base rigid part to help hold it in place. And then they have a mask underneath, so air can't get out from them, the mask, and it's just additional layer of protection that these different people are using. They're used in hospitals, policemen are using them. They're simple, they're fast, and they're pumping them out on 3D printers. And so his story isn't anything super unique because, like I said, every community is doing it in some way, shape, or form. So Impact jumped on board, okay? And it was great, and it's simple, and the design is really basic. But when I went to go print it, I ran into an issue, okay? And I have the part pulled up right here. On our 3D, and this is the bottom piece that I was trying to print, okay? And you have, if you can see it, okay, you have a hole here with a button that pops out, okay? And you have another one right here, okay, right here, and so then you have a little bit of a you have a clear lip all the way around. So how it works is we slide the bottom in here, and it has these holes on the film, and these bumps just click on, and so it adds another rigid piece on the bottom. Well, I'm going to switch, and so this is the model view. I'm going to switch to the slicing view, okay? And so I'm going to slice it along the way. So here's it after I've already ran the processing slice. So the green represents the model material, okay? And the support material along the way. Well, the problem with this design is that it is not uniform across a bunch of different printers. Where this printer here, our Stratus, okay, it has problems printing it in any way I rotate and orientate this part. if I put this along the bottom, it still has to build up these structures, so you have this layer, okay, layer to build those bumps. And so even if you come back, and this is the best way for us to print it, and we may be able to break some of this out, it doesn't necessarily work the greatest because we have all of this piece inside. And so it becomes an issue, and 3D additive manufacturing and 3D printing isn't as simple as everybody makes it out to be, because there's no way for us to get inside here without breaking away material, okay? Without us breaking it. And no matter how I built this, because there is this inner piece that's carved out, I'm going to get support material inside and it may not function. So, but this design may work on other 3D printers. And so that's just some of the ways and some of the issues that we run into. So jumping back, okay. But what happened is that during the time, we were able to, we got a few more 3D printers from a company out of Ligonier, CME CNC, and they're called the Artemis. We actually got 3 for the price of a new one of the one that got 8 by the mouse. And it was able to, the way it prints, it was able to print multiple ones without that, because it uses a little bit different of a process along the way. And so every 3D printer is not the same. So, all right. Another thing why additive manufacturing is because other manufacturing processes, okay, there are other manufacturing processes, but they become a different issue, okay? Some of them look at more detailed analysis of the part. So if we would go to make it, it would have to change throughout, okay? The tools in which they use, the designer has to have a better understanding of how the part is really made, because they have to know, well, what tools are going to be used to make this. So if we're going to make something out of wood, we have to know, well, are we going to use an 1/8 inch drill bit, maybe a 1/4 inch ball mill, maybe it's an end mill, maybe it's a flat mill. How many flutes does it have? Are we going to have to use 220 grit sandpaper, 150, 80, 600? So the person making it has to understand the different processes that are used throughout, or the different tools that they're going to need. But there are also lots of different tools they need. Where the additive manufacturing, there's one tool. It is the printer itself, okay? The processes is another thing. And I correlated this with the processes. Are we going to need to drill? Are we going to need to mill, lathe, sand, cut, grind? What are the processes? Okay. Do we mill or drill first? So with the additive manufacturing, we were able to reduce a lot of the processes throughout it, and so we're able to make things faster. But that is some of the, I mean, that's why it's gained so much steam and power, is that less and less is being done, okay? Additive manufacturing, okay? Actually, I'm going to wrap it up here, and I'm going to start our next one right here at this one. All right, guys, see you in a few moments.